Problem 10.15. Show that the mean of a random sample of a size n is a minimum variance unbiased estimator of lambda in Poisson lambda distribution. Okay, so we first need to show that the sample mean is always an unbiased estimator, and that is something we have shown in class. So here, what we need to show is to show that it's actually the minimum variance unbiased estimator. It has the minimum variance that is ever possible for an unbiased estimator to have. Okay, so remember we have a theorem from class. By that theorem, we just need to check a condition, which is using the Fisher information, right? So we just need to figure out that the variance is actually equal to the one characterized by the Fisher information. Then we can prove that essentially minimum variance unbiased estimator. Okay, so now first recall. Let me first recall what that Fisher information is. It's this guy, right? So you look at the PDF of the distribution. You need to write it as a function of the value of the random variable and also the parameter of the distribution. Then you take the derivative or partial derivative with respect to lambda, square it, and then take the expectation. Then this is called the Fisher information, which is we discussed in class. So now let's just say what is this guy here for a Poisson distribution. So for Poisson, we know that the PDF, or sorry, I should say the PMF is this, right? Where x is any non-negative integer. And then, sorry, we should have a log here. Should be logarithm of this. So here x is 0, 1, 2, and so forth. But it doesn't matter. For the values of x, what we need to do is to compute the logarithm, which by taking the logarithm of this, we get that minus lambda minus the logarithm of x factorial. And then we need to take a partial derivative with respect to lambda for this thing. So that's giving us x over lambda minus 1. Now I know that this thing here is just lambda x over lambda minus 1. So we have x minus over lambda minus 1 square it. And then to compute the expectation of this thing, I'll break the square. So I have this first thing, the first one squared, minus 2 times this plus 1. So I will apply expectation to each one of them because the expectation is a linear operation. So I got the expectation of the x squared over lambda squared minus 2 times the expectation of x plus over lambda plus 1. So now this thing here, the lambda square, 1 over lambda square can be pulled out. It's just a constant. So I have this, and also same here, same thing here. I'm going to pull out the 1 over lambda since it's a constant. So that's how I got this one here, expectation of lambda and plus 1. Then the rest is straightforward because for Poisson distribution, if x is following the Poisson distribution, then the ex square is the variance plus the square of the mean. So for Poisson distribution, the mean and the variance are both lambda. So variance plus the square of the mean. That's this. And then here, this is just the mean of the x, which is lambda. So I replace that with lambda. And then we just need to simplify it, and we'll eventually get this. Okay, so you can do a simplification from the previous line to this line, and you get a 1 over lambda. So that means this Fisher information is 1 over lambda for the distribution, Poisson distribution with the parameter lambda. Now we can move on to C. So on the one hand, we know that the variance of the sample mean of the random sample of size n, it should be equal to the variance of the distribution divided by n. So the variance of the Poisson distribution with the lambda as the parameter is lambda. So that's why we know this. I know I made a simple change. I moved this lambda to the denominator, so I could get this. Okay, now from the previous derivation, we already know that the 1 over lambda is also equal to the Fisher information, which is this. Right, so I replaced the 1 over lambda with this Fisher information, so it's 1 over n times the Fisher information. But we know that from the primary Rouse inequality, this is the lowest variance that an unbiased estimator can ever get. Now we have an unbiased estimator x bar for the lambda, and the variance indeed achieved this lower bound. So that means x bar is a minimum variance unbiased estimator.